Hi students and my dear future game changers, welcome to Yash Academy, your learning platform. It's a great key to learn everything. I am your mentor Yashwan, here to break and make the complex concepts into easy topics. So what are we waiting for? Let's learn, laugh and level up together. Subscribe to the channel and join the journey now. Let us begin today's class with the 10th class topic of chapter 1, real numbers. So before getting into the chapter, each and every chapter should be having a brief explanation and brief knowledge before starting the chapter. So once we'll be having a brief look over the chapter by mind mapping. Okay, in this real numbers concept, in this real number chapter, we'll be having different topics from this chapter. Okay, from this chapter we'll be having a different topics by the exercise wise and theorem wise. Okay, in this real numbers we'll be having a mind map. Each and every chapter will be having a individual mind map. Okay, in this real numbers we'll be having a mind map now. So let us see this. First one, introduction. Introduction will be there. Okay, every chapter introduction is common. Introduction will be there, and after the introduction, here's the main topic starts. So in this real numbers, the second topic is fundamental theorem of arithmetics. Fundamental theorem of arithmetics. Now, after fundamental theorem of arithmetics, in this fundamental theorem of arithmetics, there are subdivisions, that is rational numbers and decimal expansion. Rational numbers and decimal expansions and non-terminating decimals. Non-terminating decimals. After this non-terminating decimals, we will be having irrational numbers. Irrational numbers which does not obey P by Q form. It does not obey P by Q form here. After this, in this exponential register is there. Exponential register. In this exponential register, based on the powers and exponents, we will be having the properties of logarithm. Properties of logarithm. Okay, properties of logarithm will be there. In this properties of logarithm, we will be having 7 different types of properties. Okay, now let us see. In introduction, we will be having natural numbers which are denoted with n. Natural numbers which are denoted with n will be having 1, 2, 3, 4 and so on. Okay, after this, whole numbers which are denoted with W will be having 0, 1, 2, 3 and so on. After this, even numbers will be denoted with E and it will be having 2, 4, 6 and so on. After this, odd numbers is denoted with O and will be having 1, 3, 5 and 7. So these are the introduction of real numbers. In this introduction of real numbers, we can denote it with a diagram. First, natural numbers will be having a circle here. After that, whole numbers, circle. After that, even numbers, circle. After that, odd numbers, circle. After this, all comes under one. It all comes under one category, that is integers. So integers are dealt with both positive and negative numbers. Integer is nothing but a group of numbers which are positive and negative. Okay. After this, fundamental theorem of arithmetics. In this fundamental theorem of arithmetics, we are having a theorem called Euclid's lemma. Euclid's division lemma. In this, based on this Euclid's division lemma, we will be having an equation A is equals to BQ plus R. BQ plus R. Here A, A represents dividend and V represents divisor and Q represents quotient, multiplication here, quotient, and here R represents the remainder, plus remainder. Okay, any equation from this Euclid's division lemma will obey and work based on this equation only. So form of P by Q. Okay, P by Q. So rational numbers are nothing but which will be having 5 by 10 and 4 by 8 and so on. So this kind of fractional values will be called and considered as rational numbers. So, terminating decimal or non-terminating decimals are there. So here terminating decimals. So terminating decimals. In this terminating decimals ends with 0. Ends with 0 here. Okay. After this non-terminating decimals will be there. This will not end with 0. This will not end with 0. Okay. So non-terminating decimals will not end with 0 here. That means the quotient will be 7.4678149 and so on. It keeps on going. The quotient will be always keeps on going there. So there is no perfect end point there. So that kind of decimal numbers will be called as non-terminating decimals. So after this irrational numbers as I have said they will not be obeying the P by Q form there. So that is that one, and for example root 2, root 3 and so on, these will be the irrational values. Okay, and in this exponential revisited, properties of logarithms will be there. Those are of 7 different properties. So first one is log a power a is equals to 1, and second one is a to the power log base a power 1 will be 0. Third one will be log base a x power x by y is equals to log base a x minus log base a y. Remember here, whenever the powers or exponential value is in the division form, then automatically the right hand value will be in the subtraction form. The same way, fourth one, log base a xy is equals to log base a x plus log base a y. So whenever the power or exponential values are in the multiplication format, then the RHS values will be in the addition format. Fifth one, log base a x power n, that is equals to n is the coefficient here, and log a power x will be the value of this property. And next, sixth one, log a n to the power of root x is equals to 1 by n log x here. Okay. After this, seventh one, coefficient a log power x is equals to x here. Now, eighth one, log to the base 0 and power 0 will be 1 here. So these are the 7 logarithm properties of a chapter real numbers. Okay. So let us have a brief summary of the logarithm properties. Log base a and power a, both the base and powers are same, then it is 1 here. Now log base a and 1 is there, so it is considered as 0 here. After this, log base a to the power of x by y, when the powers are in the format of division, then the values will be in the subtraction format. So here power x by y is there, simply you can write it as split the terms and write it in the subtraction format. Log to the base a to the power x minus log base a to the power y minus subtraction. So now fourth one, log base a to the power of x into y. Here it is x into y. When it is in multiplication format, then the right hand side values will be in the addition format. Now log base a to the power of x plus log base a to the power of y. So here in between terms, see, observe the terms. Upside x by y, which is in division format, is in subtraction, which is in multiplication format is in addition format. After this, coming to the next property, log base a x power n here. So observe this x power n here. So power is also having the power there. So this x power n will be considered as the coefficient in the right hand side. So n here, n log base a and x here. So remaining terms are same here. Log base a and x. Log base a and x. So only the power extra power ki power. So the extra power of the power a, it is in the form of a power m into n. So that is written as n here, coefficient. Next, sixth property, log base a root of x here. Root of x here, root of x is written as 1 by n here. Root of value n is written as a 1 by n, and remaining values log a and power x will be same. And next, here coefficient a is given in the beginning. So coefficient a log, here base is not there, and power a power x, ax is there. So simply here a and here a will be cancelled, and log x is there, we will simply write it as x here. Now log base 0 and power 0, when the terms are same, it is 1. Same like the first property. First property and the last property are similar to each other. Whereas in the first property, both the powers and bases are a and in alphabetical order, and property 8, it is in numerical order, that is base and powers are same. When the bases and powers are same, the value will be 1 here. So that's it for today. Now stay tuned for more videos and subscribe to our channel Yash Academy. See you soon. Goodbye.